welcome to the SpaceClaim tutorial. Today we'll learn how to use equations in SpaceClaim to create curves, surfaces, and solids. First, let's take a look at how sketch-based equations are created. Let's start by clicking on the Equation tool in the Design tab. Since the Equation button is in the Sketch group, it automatically puts us in sketch mode each time it's selected. If we look in the Design window, we'll see a pink colored curve, and that's a preview of the curve type that's selected on the left in the Options panel. We can choose different curve types from the drop list, as well as create our own custom curve. Notice how X, Y, and Z fields change to reflect the curve that is chosen. These fields are editable by clicking on the either in the actual field or clicking on the Open Editor button to the right. This makes it easy to edit longer equations and to copy and paste. Interval t and scale are pretty standard amongst any curve type that's chosen, but parameters will constantly change depending on the curve that is chosen. For this exercise, let's go ahead and choose helix from the drop list. Notice that helix has X, Y, and Z fields populated and that we're in 3D mode. If Z is equal to 0, then we would automatically be placed back into sketch mode. Let's go ahead and change some of the parameters. If you're unsure what each parameter will do, we recommend clicking on the arrow next to the field and using the slider bar to verify that the preview does what is expected. Be careful not to slide too fast to the left or the right, because that might yield some unexpected behavior. Let's change the end interval to 10, the scale to 2, C to 2, and R to 0.5, and click Enter on the keyboard. We can now click on the green check mark to create the new curve. You will see the curve placed in a curves folder in the structure tree. It is labeled helix. Even though a new curve is created, we still see a pink preview curve, which indicates that SpaceClaim is ready to create a new curve if we were to hit the checkbox again. Let's make a copy of the curve and position it approximately 30 millimeters away. Click on the Move tool, click on the helix curve, click on the blue directional handle, click on the Control button on your keyboard, and click and drag the blue handle to the right until you get to approximately 30 millimeters and let go. We now have two identical helical curves. Hypothetically speaking, if we wanted to go back and change one of the curves, we have to select the curve. So let's go ahead and select the one to the left. Next, let's click on the Equation button, and then now we're back in the Options panel that allows us to edit the curve that we've selected. Let's modify C to 1 and R to 1 also, and hit Enter. We'll go ahead and hit the green check mark, and then now you'll see our helix has now been modified. Once we have curves created, we can either use them to create surfaces or even solids. The first example we'll look at is how to snap an actual cylindrical solid to these curves. Let's exit the Equation tool by either hitting Escape on our keyboard or clicking on the Select button in the Design tab. Click on the curve that we want to create a cylindrical body around. Go to the Insert tab and select the Cylinder tool in the Body group. Once you select it, notice that your cursor is immediately placed onto the cylindrical preview. Move your mouse to the right or to the left to adjust the size of the cylinder. Again, do this slowly because if you go too far, it might produce some unexpected behavior. When you're satisfied with the preview, or if you type in a value, go ahead and click on your mouse or hit Enter. You'll now notice a cylinder has been fit onto the actual curve. What's interesting about this example is the curve is still intact. If I click on the helix curve in the tree, we see it illuminate. So it's just used as a guide to create the cylindrical solid. If we look at a different example where we use the blend tool to blend between two curves, I already have one curve selected, and you can tell because it's dark green. So I'll click the Control button and select the next curve next to it. You'll see that a preview of a surface is showing, and if I hit the green checkbox, the curves are no longer in the tree. They've now been absorbed into the surface and their edges on the surface. And what we'll do next is actually look at how to create equation-based surfaces right from the get. To do this, let's go to File, New, Design. And this time, let's go to the Insert tab and click on the Equation tool. Since the Equation button is in the Body group, it automatically puts us in 3D mode each time it's selected. And if we look in the Design window, we'll see a transparent preview of the equation-based surface. Just like we learned earlier with sketch-based equations, we can choose different curve types from the drop list or create our own curve. In this case, unlike the sketch-based curves where we had an interval of t, we see that we have U range, V range, and scale being constant regardless of the curve type that's chosen. For this tutorial, let's go ahead and select a curve type of paraboloid. Once we have the paraboloid created, we can adjust any one of these values and hit the green checkbox. We now have a paraboloid surface created in our structure tree. Before we continue, let's take a look at two different ways to make solids using this example. Let's click on the Move tool located in the Design tab. Let's click on the paraboloid surface. Click once on the red arrow, tap the Control button on your keyboard, and click and drag the red arrow to the right. Once we have two paraboloid surfaces created, let's use two different techniques to turn them into solid. First one will be to use the Pull tool. If we click on the surface and pull gently to the right, we notice that we make a solid by offsetting the faces inward. We can also turn the right surface into a solid by clicking on the edge and clicking Fill to fill in a new surface. Those are two different ways to create solids using these equation-based surfaces. Thank you for watching this Space Claim tutorial on creating equation-based sketches, surfaces, and solids.